We would like to begin with our webinar on solid waste management. I welcome Professor Tanu Jindal, Additional Pro Vice Chancellor R&D and Director, Environmental Institute, Amity University, to introduce the theme of today's webinar. Ma'am, over to you.
Richa, please also introduce our guest first. No?
Thank you, ma'am. We are very blessed to have today with us Dr. Lakshmi Raghupati, former Director, retired Ministry of Environment and Forest, Consultant Environment and Waste Management, and Mr. S. Sampath, President and CEO, Samkitect Resources Managing Director, Pyro Green Energy Private Limited. Thank you to both of our eminent speakers today who have joined us at such a short notice. And we are very, very blessed to be here with you and to be enlightened with your vast experience and the knowledge that you will share with us. Thank you so much for joining us, ma'am and sir.
Thank you, Richa. In fact, with the blessings of Honorable Founder President, Dr. Ashok K. Chauhan, and our dynamic Chancellor, Dr. Atul Chauhan, respected VC Madam, I welcome both of our eminent speakers. And as the theme of the today under the Swachh Bharat Abhiyan, we were given the theme of solid waste management. The university is doing large number of activities since last 3 days, and tomorrow is the valedictory for that. So we have been given the theme of solid waste management because we divided that, everyone is doing concerted effort to spread awareness. And yesterday we did 2 activities also in our department under the club activities. One is on best out of waste, and one was quiz on the solid waste management. So students participated in that wholeheartedly, and it was really wonderful. In fact, we just work like as a family over MS team. The MS team has become our office, home, everything, It is such a wonderful platform. Though today's conference is over Zoom. So my ideas, I would like to listen to yours. Dr. Lakshmi Raghupati would be speaking on e-waste, and Dr. Sampath would be speaking on waste to energy. And they are the people who are working on the ground level in the industry, in the academia, in the research. I'm promoting the decentralization of solid waste management. That is, if we take my slogan is that take care of your own waste. So when electricity is not there in our houses, we don't ask government, okay, you provide us. We are asking them, but if the electricity cuts, we're managing with the generators, we're managing with the inverters. So we are polluting Yamuna with such huge sewage waste, and then in the landfill area, a lot of solid waste has been dumped, and it is not even treatable. It leaches down. So why don't we promote the idea of decentralization, right? So yesterday, one of our students showed the composting of wet waste, and so let us compost our own wet waste. And solid waste like paper, plastic, like I myself do at our home, I never put any dry waste to the vendor who comes to my house. Because we segregate it, we sell the newspaper, we sell the plastic, we sell the cardboards. And the wet waste is composted. So let us, decentralize it. Let us do it at our own level, at a home level, at our RW level. So I think that will sort a lot of problem for government, for ourselves, and also our river and our resources leaching from the landfill sites would be reduced. So I welcome you all again, and I'm eager to listen to both of you. Welcome.
Thank you so much, ma'am. Your direction and your guidance has always helped us bring in the best of the best webinars, and we are also blessed to have both our eminent speakers today also. Thanks to you, ma'am. We welcome now Dr. Lakshmi Raghupati, former Director, retired, Ministry of Environment and Forest. She's also consultant in Environment and Waste Management. She has decades of experience in solid waste management, in policy management, and her insight into the whole solid waste management of India will bring us more light to the very disastrous situations of where India stands today
years, because when I was in Pilani also, we used to do a lot of work where we never used to consider a waste as a waste. We used to research. And for example, if you today, when whatever you give to the kabadi wala, newspaper, bottle, etc., you don't call it a waste. You just give it to him as something which is going to be used for recovery of material. So that is the approach we are going to take with this. And under the waste management hierarchy, first option is don't produce waste. Otherwise, you reduce the waste. Don't produce, reduce, or if you have produced the waste, let's see what we can achieve by recovering the waste. I don't know, you have given me half an hour, so let me try to be very fast. So some of the things of this objective of this particular webinar is to create awareness on e-waste, because there are many gray areas and many issues which people are not aware of on the e-waste. So everybody today talks about e-waste, everybody talks about climate change, everybody talks about sustainability, but what is it in this particular area that we have to really be cautious to be safe? So if you look at the e-waste scenario, these are few e-waste collection hubs, the informal hubs which are there in Delhi, and some of them have got very well organized. If you see here, they're well stacked out. This is something printed circuit board. This is from e-Parisara. These are all not organized, and this fellow is trying to do some things, trying to arrange. So if you go to these vendors who are there, you will see they have some system of doing things. So first, let me say, because by e-waste, everybody thinks it is mobile phone or your laptop. But today, every gadget has got some electronic device to make things easy for you. And that is why everything will be ending up as e-waste. There will be something in every product, every gadget that we use, which will end up as e-waste. You have here, of course, these two are the refrigerator and air conditioners, which are known as white goods, where material is more and the electronics is less, and the others where the electronics is more and material is less. So as far as the global generation is concerned, now we have a team called the Global E-Waste Monitor, which was first published in 2014. Then second issue came in 2017, and now 2020, the third issue has also come. That is a period with a gap of 3 years. They are publishing, and the trends are being watched over the global trends are being watched. But you will be surprised to know that they are also having not enough material, enough information. So they approach people like us who are trying to patch up things, try to get some information, because unless there is a proper legal framework and people complying to that framework, there can be no accountability of waste which is being generated, especially electronic waste. So in that case, we have this one. This is the statistics where they said 44.7, which is million metric tons, which is of 2016, which was published in 2017. And today, of course, this is not showing, but the projection for 2020 was something like 52 million metric tons, but it has far exceeded. If you look at the next slide, I'll show you what has happened with the Global Monitor publication of 2020. This is 44.7 million metric tons, which said 4,500 Eiffel Towers. So, and you can see the per capita generation 6.1 kg only. But what has happened in 2019, it has crossed the 2021 level. 2021 prediction was 52.2, and it is already 53.6 million metric tons. And rate is like we were predicting a rate of 6.8 kilogram per capita. It is now 7.3 kilogram per capita. Now, this increase is very phenomenal. And at this rate, the projection for 2030, because 2030 is our target for SDGs, Sustainable Development Goals, etc., it is coming out to be almost 75 million metric tons of e-waste. How will we manage that? What will we do? Still, there are people who are doing something, who are extracting, who are removing. But what is happening is that there is a huge generations for every gadget we use, and there is a huge obsolescence rate, because of which there is a accumulated generation of e-waste. Now, as far as India is concerned, we are in one of the 5 top waste generators. Though we are a small country, but 5.2 million, which is actually 10% of the global, but still our per capita is 6.8 per capita. Though it is not very visible, we don't really see that we are using so much of gadgets. So replacements are so fast, but only when with the replacements which are going, of course, we have an upper crust of society which replaces, but then what happens is what is replaced doesn't go back for recycling or doesn't get accountable. It goes to the secondary market. Then further down, it may even go to the remote areas. So that's why the accessibility has now gone much beyond our reach to really get back or account for it. Who are the e-waste generators? We have a host of everybody, you, me, and everybody. You can put the banks, the industry, the universities, the research organization, anybody, you name it, they're all the generators. So if we really see the generators and what are the major issues? If you really scale out the issues, they're not very big. Issues are very clear. We know that this is a post-consumer waste. This is a waste generated by you and me after we use a particular gadget. Okay, period. But is that if there is a gadget which is not working, non-functional things, what we do, we just stuck it in the drawer. It's not going to matter, because if it's going to be hazardous, if it's going to blast, you will be scared. But since it's not going to matter, it's lying in your drawer. Maybe if you search your drawer today, at the end of the day, all those who are participating, at the end of the day, please go and see if there is any one gadget at least in your drawer at home. The other part is the scrap collection. Scrap collection or kabadiwalas or the scrap dealers is a very big network. It's in millions in India, across the country, and they are doing a good job to collect these. But they also do certain aspect of segregating and trying to get it recycled. But in certain areas, they are failing. Globally, they used to point out that all this electronics and electrical gadgets, including refrigerator, AC, etc., it's going into the dump site. But in India, it doesn't happen. Not many things go into the dump site. Maybe some parts may be going, but by and large, most of them go for recycling. It's not being disposed of with municipal solid waste. And now more caution is alerted after 2016 not to do it. But we have some problem with the bulk consumers, the people who consume in huge quantities, like the institutions, etc., where they dispose by auction. I don't know about Amity. I have, at least in we have told no auctions. So they do a selective disposal. They call the vendors, they call the recyclers, they call the collectors, they call the producers and hand it over to them as a take-back system. So take-back system has to be put to more functional. So we'll go through some of the bottlenecks there and we'll do it. There is another part which is the recycling in informal sector. Informal sector, it has their bread and butter into it. Even 1 gram of gold will fetch them a huge amount of money. But informal sectors have to be regulated not to do the recycling, which is really dangerous, and which, according to all of us, we know that they are using polluting technologies, and this polluting technology may really lead to some problems of the environment. Now, looking at the value chain, if you simplify the group of people who are involved in the whole e-waste value chain, is up to the product, it is your producer and consumer. You just buy it through a retailer or a dealer. Why I am putting this? Because these people have now been for the collection or take back. The other part is after you have used it, a collection agency, a collection centers. And it's very difficult in India because the Indian economy is that we get paid for the kabadi. We get paid for our waste. In all other countries, we have to pay for the waste so that the waste is not thrown here and there, and it is taken for a proper recycling or reprocessing. So we have to pay for it. So in our country, since that is not there, there is a lot of irresponsibility. So if you put a collection box, our Chief Minister Sheila Dikshit had put, late Sheila Dikshit ji had put a collection box, and there was a lot of video coverage, media coverage. Subsequently, what happened? It became a sputum because people started spitting pan into it. And whatever few gadgets were put in, they were all gone because somebody has picked it up, got it repaired, and started using. So there are many things that has happened. And as far as the the recycling is concerned, we have classified into two categories. One is dismantling, another recycling, because the end-of-life product has to be first opened up, taken out, different components taken out, and then put for recycling. Now, here, if we look at the stakeholders' value chain, you have the manufacturer or the producer who is on the top, and these sales are there. This is the same thing. I've put it in a narrative form. And as far as the recycling is concerned, we also identify the refurbishers, people who repair to a precision, and they put the genuine parts into it. The other part, these are few of the regulatory framework, because policy and regulations are important for the governance and to bring together the quantitative assessment. So initially, e-waste was a part of hazardous waste because it has huge amount of hazardous constituents. Subsequently, it has been pulled out, and in 2011, the new e-waste rules were formulated, which has been revised in 2016. I'm not going to talk much on the rules, excepting to the fact that from collection, from the point of generation, collection, storage, this cradle to cradle principle, whichever is my title, is being visualized in the regulations. And we have taken whatever is being done in the Western countries and most of the developed countries, because they have been handling a lot of e-waste for the last couple of years, certain principles of extended producer responsibility or reduction in the hazardous substances so that it becomes safe for recycling. Now, this is the definition where it says whatever is the parts as well as the rejects as well as the bulk of material which is there, and including those which are for hazardous constituents like, and the worst is because of cadmium and lead, there is a lot of liver problems, which doesn't come out visibly immediately. It takes time. And you also can end up in kidney, and worst case scenario is other incurable diseases like cancer, etc. Now, all these are showing, but there is an attraction to recycle. Why? Because it contains gold, silver, palladium, platinum, rhodium, lead, nickel, copper, iridium. So if you see the number of materials that are there, it's almost like you have 15 odd components which is identified. This is Umicore had given. And there is sodium antimonite, which is very important. So some of them are rare earths, some of them are precious metal. Mostly these are the precious resources which can be easily tapped. In our country, we only take silver, gold, and copper. We have not gone beyond that. Yes, some people have done a little bit of platinum and palladium, but even the lead from the etching and all, which is removed and it is thrown, it's not being recycled. It's not being taken out for recycling. So rest of it is still we have to do, because we have a long way to go as far as recycling is concerned. This is, of course, the main features of the 2016 rules, which focuses on the producer responsibility. It focuses on the target-based collection system, so that if there is some amount of sale, they should account for certain amount of material which is being collected back. Then you have the producer responsibility organization. This is a third dimension activity. I'll just give you some of the difference in the producer EPR, IPR, and CPR, which will give this. Then, of course, you have the system of collection or take back. Various ways, various systems have been described and in the manuals, in the books, in the guidelines, but all of them do not work. Many of them do not work because it is the will of the person who has generated the waste to go and deposit there, or call them and give it to them. That doesn't happen. That is the communication gap, which is one of the important things I have to bring. So everybody should understand that once the object is not functional, please hand it over for a recovery. It is otherwise lying waste. All the resources contained in it is going to be wasted. And it's going to be lying there and nobody will know. After so many years, you will try to see what is the fate of it. It will not no fate because there is a shortage of all these material, which I showed. All these material, almost 60% of these materials are not available. Even it's getting depleted in nature. So one has to recover from the secondary source and put it back. So I have a very good paper on secondary source, which has been appreciated, specifically with particular, in particular to one particular gadget of cell phone, different models of cell phone, how the recovery takes place. Now, as far as the recycler is concerned, all these people have to be authorized. All these people have to take permission, but still there is ambiguity in it. There is they give a bracketed approvals or authorization where somebody is a recycler and somebody is given as a recycler, but he's only dismantling. And this particular thing actually gives a little problem, because mostly when they dismantle, they hand it over to somebody else. They may even give it to the informal sector who can do some crude method to recover, or they may send it for exports. So these are the two avenues which we have to plug. That has to be plugged, but that problem is being looked after by the government. It's not our responsibility. As citizens, we have to ensure that we give it to the right person, that it analyzes to the right source, and it is taken care of. There are many good recycling companies, but they have not gone to the end of recycling or recovery. So the recovery part is still lagging. There are certain other impediments, like good technology is not available. If you want to import technology, it's very expensive. So these are few impediments. Now, as far as this is, of course, this is again a repetition of a few of the issues, because some of the issues that came up in 2011 have been rectified through the 2016 rules. So now, as far as EPR is concerned, I would like to give you a little idea about this. Has one system where the producer take back works. Not today. It was in 1990s when Ministry of Environment had a huge consignment of Modi Olivet computers. That was only given to our department because our department was dealing with WHO project, and WHO's donation it was. But within 2 to 3 years, it got off because it was not working. So then IBM came to replace. IBM is now the Lenovo. IBM came to replace the machines. So my bargain, because I was in charge of the whole thing, in charge of WHO project, in charge of all, putting PC in the table of the professors was one challenge. Nobody will touch the keyboard. They will think it will blast, or they will not have any. Today, everybody is computer savvy. So that those days it was not so. So then to take back and give another one, so I had to bargain with IBM, saying that if you will take all these PCs and give us the alternative, giving us some discount on the product, we will accept it. So they immediately accepted the offer, and way back in 1991, I could replace all the computers with the IBM, which was a higher version, which was a Pentium at that time. Pentium was one of the higher versions. Now, the other part is the deposit refund scheme, which has been, we have explored all the economic models, and this was the best one, because we can always put some money upfront in the while purchasing, and then we will await for the material of the gadget to conk, and then we recover that amount. That amount may not be available. Of course, there is always a tussle, because sometimes the kabadiwala may give more, but you should never give it to kabadiwala. We have to regularize the whole thing. So everybody, especially the students who are going to be there, please ensure that you don't give your electronic products to kabadiwala. It should go to a proper recycling company. There is also collection mechanism. They may even come to your doorstep and pick it up. And most important is the communication and awareness. So these are the three definitions of extended producer responsibility. Extended producer responsibility, EPR, everybody has heard. Now it is in plastic also. It's going to be there in some other rules also. But extended producer responsibility means you just don't manufacture and put get rid of the product, finish, that's your job. No, it's not like that. You have to ensure that the product after use comes back to you. That is the producer, or that is the manufacturer. That is the role of the person who puts the material in market. The other one is that, just what I explained of IBM, when they do individual producer responsibility, they take back. They ensure, even while selling, they will say, IBM told me, after 5 years, if you give back all this Pentium, we'll replace it with the next higher version. And they did. So likely, and the third option is if you have thankless, because this third option was chosen because there were lots of non-branded items. So the third option is that you have a moderator or a mediator. That is the producer responsible organization. Unfortunately, this new rules introduce the producer responsible organization, but they are all becoming traders. That is one of the difficult things because they are only trading. They don't even know how many items are moving this way, that way. It's paperwork and paper trading. So that is one of the irony of the system today. But somewhere there is a line drawing, and some of the PROs are doing a sincere job, very good job, and they are able to transport or transact the product to a raw material state and ask them to process it. The important part is the collection system because it's an end-of-life product. So who will build the cat? Who will do the collection? And there are a number of choices. You may put a collection box, you may put a collection center, you may put it in the store where you can drop, or there will be a drop box where you don't think you want to collect any value for the material, you put it in the drop box. So there are different options. Now, of course, PRO has become one of the active agencies to collect. So this is the material flow. After you have used it, the consumer, he requests to get it picked up, then the material is collected, then there may be a payment to the consumer that is now built in because we have put the DRS system and any other system to pay back so that consumer is not tempted to give it to Kabadiwala, give it to you. Then it goes to the authorized recycler and the recycler accepts it and recycles it. Once he recycles, he has to give a destruction certificate. He has got rid of your particular product. Now, as far as the recycling framework is concerned, this is what is being envisaged. So I just thought I'll appraise you because anybody would like to work, then I'll give you where to work, where are the gray areas to work. One is that you put the 3R principle, reduce, reuse, recycle for the EPR and take care of it. The other one is that you have the policies which will track the value chain. The policies, this is also governments. This is somebody else's, this is government. But as far as we are concerned, there is one group of people who are very active, who know the job, who know the business, who can do it, who can give value addition. They are the waste pickers and the informal sectors. They are getting neglected. Today, if you ask them, if you don't allow the material to go to them, they will starve. If you allow the material to go to them, they will do mischief. So informal sector, because the government is also drawing a line, now they have given guidelines after my insistence saying that informal sector can only collect, then at the most they can do a dismantling or opening up without any machine. It will be hand done. It will be done with hand manually, and they can use some minor tools. So you'll see some pictures of formalized informal sector. Then there has to be professional recycling companies where they may be doing a wet process, they may be doing dry process or a combination, but they have to ultimately show the results saying that this is not going to be harmful to the environment. This is the e-waste recycling in informal sector. This was not, I was not including it. Finally, at the last moment, I just said. So this is the operation of informal sector, which was originally there. Manual dismantling is taking place here. This is the dismantling. And then you have the processing. They have these drums with aqua regia, and they are trying to recover gold. So the other part of the informal sector, this is the formal sector operation. They collect place, they hold it for some time, then they open the package, then they give them, they're using tools, they have the personal protection equipments, and then they process. Even they do the desoldering. From these two extremes, this is the one which we have created, the formalized informal sector. Many of the informal sectors have been formalized to do this job, which I told you, just up to dismantling using proper tools. They have to be trained, you have to create awareness, they have to be trained, and they have to. So it's only a tip of the iceberg. We had projects in 4 different cities, Pune, Kolkata, Bangalore, and Delhi. In 4 cities, we tried to envisage what are the activities, and we got one each of the group. That the informal sector we formed into association or cooperative, so it was a group, it was not individual, so they could do it. Now after they do this dismantling, they are able to do the segregated storage here. You can see the monitor separately, the CPU separately, so they have stored, and even to the extent that they have wires, they have hard disks, their CPUs, the flat wires, then they also have the plastics, all of them separated and segregated and so. This helps in channelizing it for proper recycling. That is the only thing. So there are certain preparedness required for this. Of course, implementation guidelines and the rules are given by the government, but we have to translate them into the practical aspect and give it to them. So this part is missing. That's why I was telling Niswa also to that National Solid Waste Association, we can do this advocacy. So Sulabh is doing a training workshop where they are also giving what sort of a requirement is there for compliance, for especially for the recyclers and dismantlers. Now, as far as the challenges are concerned, there is a compliance challenge, there is a EPR system establishment, there is system, the system is lacking. We have not studied, we have the 4 different stakeholders, the collectors, the recyclers, the users, as well as the producers. Just broadly, all the 4, we have to develop different models, different aspects of their dealing. There may be so many options, but which options will they choose? You should give them the option so that they can have the freedom to choose and they comply with it. Unless that is given. So government also puts a sort of a guideline which is very generic in nature. Of course, here our Mahatma Gandhi's thing has come. It's that you have enough for your need, not for your greed. So this actually is the mantra for sustainable development. Now, if we look at the e-waste recycling, if we do a proper disciplined recycling and recover the material, we are into the sustainability. 100% because we're not going to harness more resource from the environment. And one of the buzzwords today is the circular economy. This circular economy has its origin to the e-waste recycling. The Western world learned recycling only with e-waste. They were not doing any recycling. Anything that comes out of the industry as a waste used to be shipped to Africa, China, India for recycling, including the ships which used to come to Pakistan, India, and Bangladesh. So nothing was being recycled in those countries. They were only having value for virgin material, but virgin material has its limitations of the resources. So here, if you look at the thing, there is a design stage where you really embark upon seeing that the design is for recycling. We create design for recycling, and then we can convert any waste into a resource. So waste can be a resource, either resource for recovery as a material or resource for energy. So next speaker is going to talk about energy. So he will give you an idea, and you can have a reuse. You can see what sort of uses you can put your computers. And I have seen a lot of people using the CDs for many decoration purposes. So those are all direct uses. So I should thank you because in half an hour to finish. As a teacher, I have 2-hour class, so it's difficult, but I hope I have covered everything under the topic of e-waste. Thank you very much. And thank you, Dr. Jindal, Tanu Jindal, and Dr. Richard Nagar for having taken trouble on this Gandhi Jayanti day to bring things. So let us now look at waste as a resource misplaced, not as a liability for process. Thank you.
Thank you very much. I mean, in such a short time, you have given the complete overview of the thing. Thank you so much.
Yeah.
Thank you, ma'am. The in-depth knowledge you have shared on e-waste and solid waste management will apprise all our students, all our participants on the very basics of solid waste management that we can follow. Thank you so much, ma'am. We have with us today Mr. S. Sampath, President and CEO of Samkiket Resources. He's also Managing Director of MS Pyro Green Energy Private Limited. He has more than 33 years of experience in engineering projects and about 15 years of exclusive experience in plastics, packaging, recycling, and waste management. He is heading the Pyro Green Energy Private Limited, a company engaged in plastic pyrolysis projects. Sir, we are very blessed to have you with us to deliberate on the topic. Thank you, sir.
Welcome.
Thank you. Thank you, ma'am. I hope I'm audible.
Yes, sir, you are.
Okay. Good afternoon, everybody, and thank you so much, Amity University, for organizing this webinar or a virtual deliberation on the auspicious day of Swachh Bharat Abhiyan. And I'm very glad to participate, though the short notice all, it's only for the the teaching academic people, because we are day in day out we're talking about the same thing again and again, and it is there in our hearts, so we can always talk even given a very short time notice also. And we are very happy to participate and share our knowledge to the budding students who hopefully they will get into the waste management stream one day. So I think the waste technology is a quite interesting subject because when we talk about the waste, what was produced yesterday and what is being produced today and what will be produced tomorrow will go waste one day. Okay, this is the concept to start with.
Sir, we can't hear you.
The material will definitely go as a waste. Okay, it only takes time, like something called it gets wasted. Can you hear?
Yes, sir, now we can.
Yeah, something goes. Yeah, something get wasted immediately, like we call it a single-use plastic or single-used items. Something take longer time, like a durable consumer durables, takes longer time to go into the waste stream. But nevertheless, everything goes to waste one day. Now, what we try to do is to recover, while recovering the energy from the waste, we also try to recover what is recyclables, and what is non-recyclable should go for the waste recovery. I just quickly give you through slides. So what we find you are broken your metal waste. So it cannot be used for eating, or you can use it as your dining bag. This is not working. Yeah. So those recyclables are like what is leftover items which can use purpose what we bought for, but it can be recovered, like what ma'am said, that we can pick up the precious metal or the recyclable metals or plastics, paper, etc. And what we also find in the municipal waste is the inert, which definitely not useful for any energy production. So normally plastic, glass, ceramics, etc. Maybe some of them are combustible, some of them are not combustible. We recover this. We produce something called material recovery facilities. Where we try to recover the recyclables. Then non-recyclable goes for the energy production, either in terms of heat or in terms of electricity or in terms of fuel, depending on the technology what you use to produce energy. So the idea of waste energy is one of the main reasons is we reduce the volume, because India produces, if you see on the topmost left corner, is 55 million tons of garbage every year. So 55 million tons, if you convert them with a density of let's say 150 kg per meter cube, you have to multiply 6 times, and if you want to store them in 1 year, you need so much of area for showing them. And every year and year and year, we have been using that. And the monuments in nothing, the daily people will know the monuments we have created. Dump site is growing. The main thing is now we have been negative, you have huge potential to create energy. So the volume reduction is one area because the urbanization is taking place and we don't have a place even to live or to have our own breathing place like a open space or park or whatever things like that. But there you're going to dump it. And the problem is the NIMBY's law. I mean, the professor to start with, she inaugurated said that we have to start from the home to start with. Yes, you are. If you see in a typical apartment, you take your garbage and keep it in the let's say near the staircase, and somebody spills it, and you will never ever touch it, take it back to your house, or put it back in the bin, and then because it was originally originated from you. Same thing with
But your voice is breaking. Do you have a headphones? If you could use the headphones.
I have it.
Yeah, because your voice is breaking through the computer, I guess. If you have a headphones, yeah.
Still bad?
Because if you could show some of the industry cases, that would be great.
Yeah, I mean, yeah. So one this is done, then so we have to taking care of this reduction in the landfill, and then we are talking about the value generation. From the waste, how much waste we can generate is the important issue. And also it avoids the greenhouse gases. And other fundamental thing is the emissions. If emissions in terms of air pollution, in terms of water pollution, in terms of soil pollution. Now, as we keep dumping it in the dump yard, you have all kind of a pollution like leachate formation, then the odor and insects and a creation of more of a bacteria and insects and things like that. So all these things also makes the issue for getting rid of the waste then and there. And also, if you can replace this waste with fossil fuels like coal or a petroleum product, it will be of useful. So, in fact, if you see most of the Indian industry, I mean, Indian cement industries are using the plastic, the combustible material into for their co-generation of the cement clinker. They fire along with the to bake the limestones. So during the MRF, then we also recover the recyclable. Now, if you take the municipal solid waste, we have technologies for converting the waste by thermal conversion, biological conversion, or we take out some landfill gas if there is enough gases available. But country like India, I think most of the gas is already gone because of our climatic condition. Also, most of the time people keep burning the landfills. So let's go. Thermal conversion is basically we have technology like incineration, pyrolysis, gasification.
Yeah, Dr. Sampath.
Yeah.
Dr. Sampath,
Yeah.
I think we should share your slides so that your bandwidth would increase. So, if you could stop sharing, we will share your slides and we'll be able to hear you better.
Okay.
Yeah. So please stop sharing.
Shall I stop sharing it?
Yeah. Stop sharing.
Okay.
Here from our side.
Okay. Yeah. So we were talking about the various technology available for the thermal combustions or thermal process. So the difference between incineration versus gasification is incineration as the controlled oxygen feeding for combustion. Pyrolysis is no oxygen is spread. Gasification is everything is converted into gas. So for more and more oxygen is sent inside. Now, if you say which is better, which is not better, we can always debate. But initially, all over the world, people are using mass incineration. The mass incineration is nothing but take all the garbage, feed it into the combustion chamber, and burn them off. So you calculate flying, whatever comes out of the fly ash, and whatever comes in the water comes the bottom ash, which can be further used for some applications. Now in India, mass burning is banned now because the NGT and the Supreme Court wants us to make use of the recyclables. That means they have to go for waste segregation, take out the recoverables, and then take out even the inert and certain moisture, and use the combustibles and non-recyclables to energy conversion. Pyrolysis, if you see, that's how we use. We will discover it a little later. Pyrolysis is basically from either we use pyrolysis for converting biomass into fuel or plastic into fuel. So we are specializing in plastic and rubber into fuel oil, where we heat the material indirectly and convert the solid into liquid into gas, hydrocarbon gas. This hydrocarbon gas is condensed, and the condensed liquid is called fuel oil. It is closer to let's say naphtha grade or somewhere in between naphtha and furnace oil. Gasification, basically what we produce in gasification is syngas. You burn everything and then the temperature inside the gasification chamber is much more higher than incineration, which is around 950 to 80,000 degrees centigrade. Pyrolysis operates around 450 to 500, maybe 600 degrees centigrade. But gasification, we go beyond 1,200, 1,500. If you look at the clean technology, gasification definitely a clean technology, and followed by pyrolysis because there's no oxygen, there is no oxidation, therefore there's no emissions. And so gasification, then there is a direct gasification. There is you just burn it with more of oxygen, or you can use plasma torch, where we induce energy to create more higher temperature gas, where we can crack the syngas into CO and H2 and other components like. Then we do some chemical synthesis to convert them into alcohol or chemical methanol, ethanol, propanol, etc. And also liquid CO2. When we talk about the organic and food waste, what we do is we take out all the foreign material or plastics, paper, clothes, etc. And then pure organics or food waste is made into some kind of a pulp for easy digestion and feed into the digester. And the digester, during the digester with the microbes, it gets fermented and then it produces the methane gas. And the methane gas comes out, you store it in a gas balloon and then produce. Either use it for heating or for producing the power. And whatever the water is replaced every day is used as a liquid fertilizer. So that's another way of producing power. The natural from the landfill, you can always trap methane gas to light out. I mean, you can't really produce energy, but you can burn them up, use it for little bit of burning. So let's go to the next slide of the total ecosystem what we're talking about. If you see, there are two kind of material comes inside or any waste in treatment plant. So the fresh waste and the existing landfill waste, we call it the legacy waste. So we have to do the treatment actually. So the treatment is basically I told you that is material recovery. So you treat them, try to take out the inert, try to take out the metal, try to take out the moisture, so that the energy efficiency is improved and also the recyclables are taken out. So from the landfill, we take out the combustible materials and come for the waste energy plant. And the waste energy plant, depending on what technology we use, we convert those material into energy. And the food waste and organic waste goes to biogas digester and then digest and produce biogas. That biogas, from the biogas, we can produce energy. and the leftovers like some of the liquid fertilizer or some technology that you can produce the solid, semi-solid fertilizer with biomass and compost. And you can, so therefore we generate sometimes more steam in this during the process, electricity, then we produce biogas, recyclables, then we get the burned bottom ash which can be used for low-lying, filling the low-lying area or using as a pavement of the road bed, etc. And some post we get some other carbon, although we get some kind of carbon credit which was quite good. So with the waste which we call when we look at the waste, but when we convert them into this kind of a material, it is definitely increasing the value. So go to the next slide. So we just talked about the thermal technologies. I already briefed you. This material preparation, the next slide is material preparation. So we are focusing on MRF, that's material recovery facility, to produce RDF. RDF is refuse derived fuel, or we call it as a SRF, that is solid recovered fuel. So the SRF has got this DIN number, RDF doesn't have. The concept is next slide. Is concept is we bring the material, we put them in the heat shredder, we shred them, or you can call it a bag opener. We just open all the bags or open the big blocks into small pieces, and we take them to from a screen or a rotary screen, and we try to separate out the organics and non-organics just by the size. Like 100 whole size of the trommel, try to take out as much as the vegetables and leaves, etc. as a predominantly the organic portion. And above 90 mm or 100 mm, we go for the RDF facility, production facility, where we have, the next slide is, we feed the above size of 100 mm into the shredder to bring the uniform homogeneous size. We try to take out all the ferrous, non-ferrous material, try to take out the inerts through the fire screen where the thousands of wheels move around and then it beats the material and take out the inert. So a little bit of moisture loss comes out from there. Then we have an air classifier. If you see on the right side, and after the eddy current is affected, then we have air classifier. The air classifier is nothing but laminar flow. Air is pushed and the municipal waste falls into the system. And because of the power or electricity, three different projections are formed. The heavier one was closer to the machine and in closer, and the medium falls in the middle. And the lighter structure goes on the way, which consists of basically two-dimensional material like plastic, paper, leaves, and textiles. So those material is taken for the power production plant as an input material. When we talk about the technology, so what is how it's done, and the recyclables goes for recycling, and the RDF what we are producing RDF goes to the power plant. Here you see there's one more shredder which sets the material further to downsides of let's say 25 mm. This is depending on what kind of burner we are using it. If you are using a circular fluid CP boiler or bubble type boiler, then means smaller size of the particles. So typical the IF plant or a segregation plant looks like this. On the left side, the material comes and falls on the yellow color the feeding conveyor. It is shredded and then goes in the conveyor. First one we have a magnetic belt which removes the magnets. There's some reject conveyor. Then we have the inert separation. After inert separation, it goes to the classifier, the heavier fraction, medium fraction, and the lighter fraction goes to the end. Next slide, you see this is a typical plant working in Thailand for processing 2,000 tons per day. From the right side, the material is come and dump here, and then in the bunker because in a storage area bunker, and that is through the conveyor to the thermal screen. From the thermal screen, anything less than 90 mm goes for the organic waste as organic treatment, organic waste treatment, and the whole line is for treating the collecting the combustible material which is stored in the site. So this is how so municipal waste education was a very key thing for uh, producing the efficient energy. Uh, if you want, because we don't want to put the non-combustible material into the incinerator or combustion system and don't produce anything. I mean they don't contribute anything for the energy. I have a small video whether you will produce or I will show that. I think I'll show this video. Shall I show this video, ma'am?
Sir, video is not
Please
playing.
share the video.
Yeah. Let me check. You cannot. But what I sent is only PDF because it's a movie, but otherwise we can skip this. Disable share. No. Okay, I think I'm not able to share the movie. We can show this. Let's go back a few slides back, and we were talking about the insulation. Okay, we talk about insulation. Insulation is basically, I told you, basically it is with the limited oxygen, so we burn the material inside, and it has got different kind of beds. One is rolling bed, other one is 2 days bed. Related to that slide. Towards the end, we have a grade 5 bed, that is traveling grade or moving grade, or we have a circulating fluid as bed where the material is circulated along with the sand. The bubbling fluid as bed is out, it bubbles, it vibrates and then convert along with the sand, and it convert the material into you get combustion and produce heat. So the side wall of the heating combustion chamber is consists of with the pipes which will use high pressure steam, and that high pressure steam goes to the steam turbine and produce the power. I mean, that's the concept. So if you see the typical waste energy plant, it starts from the left hand. We have the pre-processing where we have a thermal screen, we have the shredder, we have a magnetic separator, eddy current separator, air classifier, and fine separation. After the whole thing is done, it's almost like the product goes into the silo. From the silo, it is fed into the combustion chamber, and in the combustion chamber, we can see what all things there. So the next one is okay, the advantage. What in a typical incinerator, have the fuel feeding system into the combustion area. Then we have the combustion accessories like the air quantity, the primary air and the secondary air. Under the combustion chamber, we have the collection system of ash collection system. So the burnt ash comes down, falls down, and then that is collected and used for thing. And whatever is fine, the fine ash also trapped in the one of the and then drop into the segment of moving rate. So that unburned material again is burned in the one of the last chamber, and only the complete combustion takes place the whole chamber. In other words, the incinerator has got 5 or 6 modules depending on the material we will handle. The first module will will be used for basically for drying the material. So take out the moisture. The second, third, fourth will be the real combustion, and the fifth one will be the unburnt material is guided back and then burned again, so that the complete combustion is taking place. While heating while producing the energy, the water is heated to 4 and 5 degrees centigrade of steam with 40 bar to 80 bar pressure, and it goes to turbine and then produce the power. So apart from that, you also have a flue gas cleaning system where you use ammonia cleaning, urea cleaning, then water scrubber, dry scrubber, and the ESP, etc., depending on the kind of toxics what they produce. And these are the components. Then water waste cleaning system, water treatment system, and electrical system, and compressor system. Some of the components of this. These incinerator can process any biomass like agricultural waste. Apart from the municipal waste, you can use sewage sludge also. You can use it because you've got a bunch of trapped methane in that. Then you have all kind of rejects like plastic rejects and fibers, clothes, etc. Municipal waste. So whatever is combustible can be fed into the combustion chamber to produce power. Yeah, the next one is the type of boiler what we just wanted to show to you that there is a moving grate which is very common. This moving grate on the left one is the moving crate is the crate fired boil instrument is very common for common in India and many places mainly because the particle size is very not fine. I mean you need a rough shading and then maybe about 150 to 200 or even 300 size of particle is good enough. And it also even in the mass burning system, the moving crate is used. But if you're going for the circulating fluidized bed or a bubbling fluidized bed, then you must limit the size to 25 to 30 In that case, what happens is material is circulated along with the hot sand and keep going, and while circulating, the combustible material get converted into heat or vaporized. So that's the concept of that. So a typical, if you see a typical cross section of the incinerator plant, you have the pit, waste pit, where the we are assuming in the 3 modules. So it's get combusted when the in the boiler the steam is generated and the steam goes and runs the turbine, steam turbine, and there are accessories like cooling towers and emission control equipments are used. So let's keep a couple of the next one. What people in the there are technologies where we use the so you don't feel the cold firing in this combustion chamber. So this also helps for energy saving basically. That's what I just wanted to tell you that. A typical next slide please. The typical this is the feeding of material towards the combustion chamber, and if you see the 1, 2, 3, 4 models are visible here. So each model has got some blocks, and the whole thing is burned, and the bottom ash is collected on the bottom, and the whatever the pipeline you are seeing is for the air supply and cooling system. Okay, now let's go to the straight to the issues with the fire. Yeah, the fire basically now one of the fundamental problem.
Excuse me, sir. So you're not audible. So may I also interrupt to say we are a bit over schedule. Could you please wrap up in 5 minutes, sir?
We can't hear him.
So we really can't hear you.
He should come near the microphone of his laptop and speak.
Sampath sir, please off your video.
I presume there are some connectivity issue from his side. Sir, again, we can't hear you, sir. So we are so eager to hear your conclusions.
Hear or is not? Shall I join
Yes,
back?
now we can hear.
We
Now
can
we
hear you now.
Now you can hear.
Yes,
Okay, I
sir.
think it has
So
taken a break. Okay.
if you could conclude about different processes, if you could summarize.
Yeah. So therefore, what projects are not popular in India. So there are many reasons apart from the political reason. Then the technology selection of technology played a major role. Most of the and the estimation of the quantity, content of the quantity was totally poorly estimated. So therefore, the failure is due to the technology and the kind of unreliable data about the waste, available waste, and then the quantum of combustion material. Now, when let's move on to the pyrolysis. Pyrolysis, as I told you, is for technology where we indirectly convert these solid plastics into liquid into hydrocarbon gas, and we get from this pyrolysis, when we process the material, we get the hydrocarbon gas, which that we convert into oil. Then the excess gas, especially the initial gas of C1, C2, C4, we use it for heating again our reactors. So the mediums through the almost like LPG gas is not there. Even if there is any gas at the heating temperature about of about 1,000 centigrade, toxic dyes. And we can process system. Yeah, next slide, please. We can process all kind of plastic. I mean, the pyrolysis cannot do the size of what incineration and gasification can do. This is for the decentralized area where we talk about 10 tons of plastic, 20 tons of plastics, or even less than that. Whereas combustion or gasification, I mean, incineration or gasification, you need at least 300, 400 tons per day. So the process is for the decentralized area where we can convert the plastics into
Sir, I'm sorry, but we have lost the audio again.
Keep showing the slides, at least people can see the slides.
Oh, one PET and PE, we use a carpet which are used, the tile carpet, which is again PVC and nylon or TP, nylon and my audience, I don't know something wrong today. The system is not doing.
Yes, there's some connectivity problem, so your audio is lost.
So I think I should record it. Can you hear now?
Now, yes, sir. Sir, maybe you can switch off your video. The connection is a bit slow.
Shall I rejoin? Can I go out and come back? Maybe it may work.
It would be wonderful if you could conclude in few lines.
Camera, your bandwidth will increase. You please put off your camera, not the slide.
Even I can't hear Professor Davos.
Put off your camera and rush through the slides. That will be better.
Yes. So we are able to read the material.
It's muted. Even Professor was also not audible.
Yeah, please scroll through the slides, please. So this is stationary reactor. Yeah. And next, please. Plant 2. Okay. Next, please. Running plant in India. Okay. Next, 1 ton per day. Okay. Then 10 one commissioned in 2016. Wonderful. Okay. Next. Next, please. This is latest 5 in 2019. This is okay. Nice. Yeah. Next, please. Carpet waste of fuel oil and electricity. Okay. So this is the output quality, specific gravity, and all the details have been given. Next, please. Emissions from chimneys, particulate matter, CO2 and carbon monoxide. Okay. Stack emission. Okay. From CPCB. Results are okay. Can you go back? Results are. Can you go back? Yeah. So this is 115 mg is the CPCB standards, and all are below the
standards. Yeah.
Below the permissible limits. Yeah, very good. Next, please. Biogas from biomethanation. Next. Organic wet waste to biogas. So okay, these are the typical digesters: slurry, settle, effluent. Yeah. Dr. Sampath, you can speak. I think you're audible now. Please, stages from the waste to power. Yeah. Then stage. Next, please. Any questions? Okay. Yeah. So it's a very wonderful presentation. In fact. Yeah. So like I would like to know like how many waste to energy plants are there total in India? Hello? Can you hear us? I think there are some internet issues. So shall we conclude, Richa?
Yes, ma'am. I think it was a very beautiful presentation, sir. But due to a connectivity problem, we can't hear you, and that is our miss there.
I'm lost.
Sir.
Yes, sir. Thank you. Yeah.
Thank you so much. With that, we would come to our conclusion. That is, Vaishno Vajanto Tene Kahiye Je Peer Parai Jane Re. With a short remembrance to a man of words, wisdom, and practice, Mahatma Gandhi. We come to an end of a very fruitful webinar today. I thank our Honorable Founder President, Sir Dr. Ashok K. Chauhan, whose guidance is unparalleled. We thank Dr. Atul Chauhan, our Honorable Chancellor and President, Sir, for his dynamic leadership. We are thankful to Honorable Vice Chancellor Ma'am, Professor Balwinder Shukla, whose encouragement and guidance is always very important. We are most thankful to Professor Tanu Jindal Ma'am, Additional Pro Vice Chancellor R&D and Director AIES, Amity University, for arranging this most enriching webinar on solid waste management. Thank you, ma'am. We are highly obliged to Dr. Lakshmi Raghupati for sharing such a wonderful knowledge base on solid waste management and an engaging presentation. Thank you so much, ma'am. We are also very thankful to Mr. S. Sampath for sharing his experience in the working area of solid waste management and to enrich us with actual scenarios. We are also thankful to all our panelists, faculties, and students for joining us, and I'm also thankful to IT for all the support today. Thank you all. We will close the session now. Thank you, ma'am. Ma'am, with your permission, can we close the session today?
Yeah, please. Thank you. Bye.
Thank you.